Modern transportation systems on land, on the sea, and in the air are vital to our way of life. To move people, commodities, and materials. In this jet-propelled age, people are in a hurry. With an urge to go places quickly, they become impatient. Rightly or wrongly, they demand the right of way, frequently losing sight of the hazards of haste and taking shortcuts. Modern transportation systems are in use throughout the mineral industry in both underground and surface mining. They are essential for moving mine products, workmen, and supplies to fit the fast tempo of mechanized mining. Belt conveyors, like all other forms of transportation, have specific hazards for which safeguards must be developed to avoid personal injuries, equipment breakdown, and loss of production. Belt conveyors are not a recent innovation. They have been used many years for all sorts of industrial applications. In mine transportation, belts have been used for more than a quarter century. Their use has been stepped up in recent years because they offer continuous, rapid transportation for the flow of products. Belt conveyors present hazards, inherent and man-made. Their wider use under new conditions has been accompanied by an increase in the number of moving parts, such as reduction gears, rollers and idlers, drives and pulleys around which conveyor men must work. The greater number of moving parts not only increases maintenance requirements, but also increases the chance for accidents. Usually an accident happens when it is least expected, injuring someone who least expects it, like this workman, for instance. With the belt running, Mike was cleaning up around the belt line when he noticed that a roller was sticking. He tried to correct the situation using a screwdriver. Investigations reveal that 1/4 of conveyor belt accidents occur at the head pulley and troughing idler. To reduce such accidents, hazardous areas must be effectively guarded. Lighting installed to permit visual inspection without entering the guarded area, and bright painted signs should be posted where needed. A common belt installation is one for transporting ore from a dumping point to the main haulage road, where it discharges into cars for transportation to the surface. One of the most dangerous practices around a conveyor belt is to take a shortcut over it while the belt is in motion. Guarded crossovers are usually provided at points where it is necessary to cross over moving belts, but workmen don't always use them. In addition, a belt control line by which stop switches can be activated should be provided along the entire length of the belt. When workmen decide to take a shortcut over a moving belt rather than walk to a crossover, they invite trouble. His buddy hurries to pull the stop line, but it's too late. There are 3 steps necessary to discourage the unsafe practice of workmen taking shortcuts over moving conveyor belts. First, a survey should be made of the places where men ordinarily cross the belt lines. Second, crossovers should be installed at these places. And third, we should insist that only the crossovers be used. Here is another conveyor belt accident. The foreman instructed Tom, a conveyor man, to clean up the spillage around the drive motor and mechanism at the drive pulley. Tom noticed some spillage inside the guarded area, so he attempted to reach inside the guardrails with his shovel. "84% of conveyor belt accidents occur during cleanup operations. In order to reduce accidents of this type, much care and forethought are required. Sometimes the basic hazards are overlooked. A conveyor man may forget that a moving belt is dangerous. But if all gears, fittings, shaft ends, couplings, and guards are installed, then necessary work may be performed in the vicinity with little possibility of personal injury. Another common type of accident occurred when 3 conveyor men were repairing a splice on the tailings loadout belt. The belt on which repairs were being made was 18 feet above the ground. 2 of the men were on the belt. The other was on the walkway alongside the belt. A small refuse belt line was in operation, but it became necessary to stop it when a chute feeding into it became plugged. After the chute was cleaned, an employee, unfamiliar with the conveyor system, was sent to start the refuse belt. He mistakenly started the main belt line instead. One workman was safe, but the others suffered severe multiple injuries. Accidental starting of machinery under repair can be prevented by providing maintenance men with safety locks to lock out control switches. This procedure should be strictly enforced. Accidents happen when least expected, and investigations reveal that they occur with a higher frequency when work is being done in a hurry by someone like Clarence, who today arrived at work 15 minutes late. He did not report to his supervisor, but proceeded to his routine work of checking and cleaning around the belt and pulleys. He was seen doing this cleanup work shortly after he arrived, using a long bar with a steel plate attached to one end. When he observed built-up material on the tail pulley, he used the bar to clean around it. The bar became entangled. He stumbled and fell, and was pulled into the space between the tail pulleys and shaft ends. The direct cause of the accident was carelessness, the failure to stop and lock out the belt before attempting to remove adhering material from the pulley. Conveyor belt fires, especially in underground installations, greatly endanger life and property. Numerous belt fires have broken out during off-shift periods after belts have been shut down. A common source of conveyor belt fires is heat developed from electrical defects in the driving mechanism, which is transmitted to the belt. Also, heat from friction can develop at drive or tail pulleys and at frozen trough or return idlers. Once started, a fire involving a flammable belt usually spreads rapidly. The combustion produces high temperature and dense, highly toxic smoke. To combat conveyor belt fires, workmen should be trained in firefighting and the use of proper fire extinguishers. Fire extinguishers should be maintained in good working condition and should be available at convenient locations. Frictional heat is also caused by belt slippage due to faulty belt tension, foreign particles, and overloading the belt. Frictional heat developed at the drive pulleys, tail pulleys, and at frozen trough or return idlers is often caused by worn-out bearings or lack of lubrication. Frictional heat may develop at any place along the moving belt where it rubs against a stall part or obstruction. This can be overcome by having control switches in the driving motor installation that will automatically stop the motor when the belt slows down, slips, or stops. To prevent belt fires, all belts should be fire resistant and the entire belt system carefully aligned. To prevent electrical breakdowns and overheating, the importance of first-class electrical installation, including properly rated switches, circuit breakers, resistors, and conductors, cannot be emphasized too strongly. When two or more belts are in series, automatic means is necessary to start and stop the belts in proper sequence. All moving rollers and idlers should be inspected frequently and lubricated to minimize the occurrence of frozen or stuck parts. To eliminate spillage, certain mechanical aids must be installed around hazardous areas. Feeders must be so designed to evenly distribute the load across the belt. Skirt board should be placed to prevent side spill at discharge points. Special containers can be installed to catch dirt cleaned off pulleys by scrapers, and effective wipers that clean belts should be placed so that workmen cannot clean them while the belt is operating. Extended grease fittings and other mechanical aids should be installed so that work can be performed from a safe distance and not as shown here. Maintenance and repairmen should be provided with safety locks for the purpose of locking out main control switches while repair is being performed. Safety rules should be posted conspicuously and employees instructed to obey them. A positive approach on the part of workmen and management is necessary if conveyor belt accidents are to be reduced. Safety-minded management can work out solutions to new or hazardous problems. Safety-conscious supervisors can translate the solutions into action, and safety-minded employees can perform the work according to plan safely. Supervisors must provide leadership and, by good example, encourage safe belt operation. They must also caution workmen frequently about the hazards. The crux of an effective belt safety program is keeping the workman alert and willing to do his part to prevent injury to himself and to others.